Very good. Welcome on stage, based in Berlin. Quantica, I mentioned earlier, they will be hosting a nice tour at our event on the 16th of October, showing their multi-material printer. And Marcel, feel free to go ahead with the screen share.
Thank you very much. I'm very happy and glad about the speakers before I joined this stage, because what you have seen in the presentation before is printed electronics with inkjet version 1.0, and now I'm presenting you 2.0. And I'm looking very much forward to what could get created out of that meeting, because we are on a heavy edge of technology development in regards of what kind of inks and pastes especially can get printed. And therefore I called it a little bit provoking digital screen printing, the future game changer for printed electronic manufacturing. So who we are: Quantica is a startup with more than 50 people in Berlin. We are a tech developer and provider. We are not that deep in printed electronics, and I will tell you why later on, and why we are looking for partners, because we do need these 50 people only for the sake of developing a new printhead technology and the printer around it. The company was founded 5 years ago for the sake of printing electronics in a very functional way, to utilize the printed electronics as prototypes, and furthermore, and later on, also as serial produced PCBs. And just for that challenge, we do need more than 50 people, having 6 development departments, because we have to develop everything by our own, because we can't buy anything, because it doesn't exist. So what we are aiming is, we would like to print voxel by voxel. We would like to print multi-material, for sure. That's the reason why we decided to go for inkjetting. And it's internally, we can print multicolor and multifunctional. We would like to print, and we already does, high performance. High performance means printing high viscose material, and therefore high functional material, and utilizing the inkjet process as an all-in-one process, so not having different process steps after each other. And to make it short, where we are and what makes us different to others: the legacy inkjet can print viscosities for inks somewhere between 15 and 20 or 25 centipoise at jetting temperature, and jetting temperature is most likely somewhere between 60 and 80 Celsius. And we can print 380 and more. And right now, this is our daily target, to exceed the 400 centipoise. And there is one printhead in between. It's the XAR high viscosity printhead. XAR is claiming to being able to print somewhere between 70 and 90 centipoise. We haven't seen it yet, but we have seen, and you see it on the samples on the right, we are printing up to close to 400 centipoise. Means we are printing real SLA and DLP materials. As you've seen with the denture, this is already certified dental SLA and DLP material. And the black with this small watch, this is Loctite SLA, high temperature resistant material. It's the very tough material of them, and we can print. There's a bone material in the middle of this finger, and a tough and a soft tissue material around it. We can also print multifunctional parts with soft parts and stiff parts, but I like to focus way more on functionality. And where does the functionality comes from? It comes out of our printhead. Our printhead is designed to print materials up to 400 amperes or centipoise. This is the printer we are going to release at the end of the year as open research platform. Open research platform means you can try it with your own inks, and you can utilize the printheads with a parameter set of your choice. So you're not limited or restricted to anything, just to try out whether your material is printable or your application is printable or not. Somewhere in the middle of next year, we will then